Welcome everybody, you're watching Mr. Fugu Data Science. Today we're going to do some sentiment analysis of New York Times data using Python. Before we get started, thank you to the recent subscribers and viewers. I greatly appreciate it. We have two examples today. The first will be parsing, removing stop words, punctuation, and symbols of our data, then evaluating the word frequency. The second example will be also from NLTK using Vader, where we will take a score of each article or sentence and determine if it has a message, an underlying message, which is positive, negative, or neutral. You're going to need quite a few confusing imports today, so please stop the video and look at this. Now, today's basic idea, I want to give a little bit of background on what's going on with text mining. You have to consider a few things. You have the tone, the complexity, the colloquial terms, and the context, which are very important and not easy to distinguish. And you have to determine, are you evaluating individual words next to each other, or entire sentences or documents? This could become extremely complex. For instance, a normal conversation can mean something different from one person to another, especially in terms of specific domain. For instance, if I'm talking to my friend about something versus talking to a statistician or somebody who works with economics, it can mean a totally different thing. There's two main concepts we'll think of today. Bag of words, or BOW, is just basically looking at word occurrences in a document, And then Vader is the valence, aware, dictionary, and estimate reasoner. So this is a sentence level classifier and is based on a list of words with scores designating if it is either positive, negative, or neutral. And it's basically based off of a rule approach for the rating. And the context of your sentence will be captured by the punctuation, capitalization, modifiers, conjugation, and prior trigrams. This is pretty good if you're using a short text or some kind of post, like a social media post. It's not good if you're using like some novel or trying to do any kind of like financial analysis, okay? Please be aware of the disclaimer that I'm putting in my videos now, just as a heads up. So this New York Times API, we have the most popular articles for a specific time period. What we're looking at today is the media, title, and abstract. These are the three short headings that you'll see for like some news post, and what we're concentrating on is the most popular articles for, I think it was the last 1 or 2 weeks. Okay, so if you noticed here, we have media, title, and abstract, and these are for one entry, but you'll see that they're slightly different. All right, so it says that obviously something happened to somebody when they were taken down by the FBI, something bad happened to them, and then it says the suspect was in Portland and they were arrested, and then the abstract gets a little bit more in depth. All right, it's like 2 sentences instead. Now we have around 20 entries for this that we're going to parse through. Here's what the data looks like that I scraped from the website. So this actually parsed these data. I'm only concerned with these 3 columns. We're going to take all rows with that. And we have to do a few things. We need to remove the symbols and punctuation and then convert everything to lowercase. And here's an example of what's going on if you're taking away the string punctuation, all right? And then I show it here if you were doing a regular expression pattern matching, if we were looking only for the punctuation, but that's not exactly helping us with this matter because we want to keep all words and remove punctuation. Therefore, this string join with this list comprehension is really what we're looking for here. So let me zoom into this so you can get a clearer picture. All right, so we're iterating inside of it, but in this case, there's one more step that we need to do, which was also taking out digits, which will be shown in a second. So I converted our data frame into a iterable, which will be called items. So we're taking this as a dictionary. We will need to create a dictionary list where the values will be a list of values and an empty string that I'm going to store in first. So I need to iterate inside of my dictionary and then iterate once again, but going inside of this nesting and look for anything that's a string. And if it's a string, we're going to use a regular expression to take all words. And the tokenizer is splitting our sentence into a list of strings, which would be individual words. And what I did was I did this in a few parts. I took my tokenizer and I did my string join with a list comprehension where I convert it first into lowercase, then I am getting rid of all my digits, and then the outermost part, I'm finally splitting all of my words And if I have an empty list or string, I'm just going to append it with nope, okay? Or nada. I did this 2 different ways, but this one I'm not going to keep. Then I have to iterate inside because I have a list of lists and create my default dictionary list where my key is my title, abstract, and media, and then all of the list of lists are my values, all right? And I printed it off as a dictionary so you can see what's going on real quick. And there's a few things that we still need to parse out. So for instance, we have to take care of what are called stop words, like things that are useless, don't have any context. We also have to figure out how to deal with this nada since it's nothing. We could have just left it as an empty list, basically. There's other things that we need to take consideration of, such as this NYC was N, capital N dot Y dot C, all right? And that's something that's really frustrating to deal with because we had a few acronyms and abbreviations for FBI and Department of Justice and things like that that have context but will be lost basically in translation unless you figure out a way to deal with those. And that's an important thing for text mining or natural language processing. There's a few things that you can do because this is an important area of research if you come across this in your field or in some kind of project. I would suggest you either create a list of stop words that are custom or try to do like some fuzzy string matching and have a list of words that may match up with these list of abbreviations or acronyms. If you're only dealing with, for instance, social media posts where they have very specific abbreviated words or acronyms, you could download a list of those and keep those as your stop words to do some kind of comparison with and add them in so you're not completely losing these when you're doing your analysis. For instance, if you were doing biomedical research, these abbreviations and acronyms are extremely important, and I left 2 resources that you could evaluate if this comes up or something you may need. For brevity, I decided to ignore those in this case just so we can get an idea of how to deal with this. You call in this corpus to get your stop words in whatever language I'm using, English obviously, and I'm iterating inside of my list. I'm dealing with the nada or nothing, and I'm just appending that as a empty list if it comes up. And if we have anything else, we're going to use a list comprehension, and we're going to take care of anything that's a stop word. We're going to then need to iterate through that and create another default dictionary so we can get an idea of what's going on here. But you still have one little hiccup. I'm going to show you that now. So if we scroll down, you can see these individual letters are not taken care of with the stop words. And you have to consider to yourself, did I just make a mistake? And no, I did not make a mistake. And you have to verify this by looking at what words are in the stop words. And for instance, you could do a comparison with some of these to see if they are or are not in the stop word list. So now we need to remove those. And basically, you could do a situation like this where you have your list of words you're trying to evaluate, and you could do some kind of comparison to make sure it's at least larger than 1 letter. And if it is, you just take that out and you keep it. So that's basically what came up here. So then I just added this in to the same code above and placed it here for our stop words so I could do everything in one shot where I'm getting rid of the single letters as well as the stop words and appending everything to the new list. So if we scroll down, we don't have it anymore over here. If you notice, we don't have the N and the C or the P that we had. In this one, there was an E because it was an abbreviation for this person's name, E. Jean Carroll. Now, if we needed, for instance, the frequency count of words, what happened in each one of these lists, in this case, it's not extremely important or relevant because we have short sentences. You're dealing with 1 and 2 sentences. If you're dealing with documents or paragraphs, which would be each one of these lines, let's say, or even whole text, this would be extremely important, especially if you wanted to perform any kind of analysis or plotting. Nevertheless, this code is still relevant and allowed me to use this right here from NLTK called frequent distance, if you see this. And that's how we got these frequencies for each one of these words in the list for everything that's in the data frame. Something interesting, if you do not know how to iterate over a full data frame, today you get 3 examples of doing it, which can help you out and garner a new skill. Now let's do our second example, which is using the same data but starting from scratch. We're going to use our Vader from the NLTK, and I'll suggest maybe you want to stop the video or get the code off the GitHub so you can follow along with me. We need to create something to store this in for our SIA, which would be our Sentiment Intensity Analyzer. And let's realize a couple things, all right? This is the same that we did above, but we don't need this for this case. We could skip right here, because all you need to do is take the data frame that we converted in the very beginning to a dictionary, iterate inside of that, still do our comparison of strings, but now you're adding in this scoring that we're using for the neutral, positive, or negative scoring for each one of our list of strings. And basically what's going on is it's comparing each word and giving it some kind of score. Is it a positive word? Is it a negative word? Is it a neutral word? And then I think it's either adding together or it's averaging. I don't remember, to get your compound score. I did two separate ways, where this one I am collecting all of the scores total versus taking only the compound scores, which we will use for the plotting, so you can see what both of these look like. As usual, if it's not available, I just say we have a nope. I create my default dictionary as usual and print this off. This is all of them together. So for this particular line, I had this particular article, title, abstract, media. These are the scorings that you get put together if you want it in this format. I wanted to do the polished up version, which we'll see in a second, which is this. And you'll see that we have the title, the abstract, and the media, but these scores here are the compound scores that we took out here. The compound score is that it's either the averaged or the added sums. I don't really recall. I'm not clear on that. Here, how would I deal with anything that's nope if we're going to do some plotting? I could set it to 0, but that I don't think is very useful because that's deceiving, because that would connotate that we have a neutral kind of a score, basically. And I don't want to say that. So I'm going to put it outside of the range of -1 to 1 on purpose so I could visualize it and understand what's going on in the plot. And I do this so then I could still have the same amount of published dates, yet the number of occurrences here for the plotting would be misaligned and gives me an error when I plot. So I concatenated everything along the columns from our data that has our compound columns with the date, and I had to change the data type because these are dates, so I had to convert it into a date time formatting. Then I verified by printing out, indeed it is a timestamp variable now, and I got into doing some good old fun plotting. If you want to see how all this is done, you can pause the video and look at this in depth, or go on my GitHub and feel free to play around with that, okay? And I could scroll kind of slowly, so if you do need to pause the video and have some kind of interest in this, fine with me. Today's just more of illustrative purposes instead of coding, because otherwise the video would be like 45 minutes, okay? So let me explain what's going on with this. So I plotted by day that we had the articles from the range of values from -1 to 1 are what the score and compound numbers are. I intentionally placed numbers outside of that region so then I can know that, hey, these values were not given in these data. And what we have is the title, abstract, and media. And if you notice, one thing's clear from, maybe a day or two after August 25th of 2020 till about, September 8th, or so, there was a lot of negative news. There are a few articles here that were positive, and I plotted all these three together to kind of get an idea and say, how are these titles or short captions of text looking next to each other? Are there any differences? Are they fairly aligned with each other? Are there any stragglers? And without having a label on each one of these data, it becomes a little difficult because, like, for instance, here, you notice that there's overlapping. Is it just one thing overlapping? Multiple things overlapping? How many actual articles are for this day? I can't distinguish which one is what. This one looks like it's only one article for one day, but it looks like you have some really oddball values here that are totally misaligned. You have a title that looks positive, but you have a abstract and then media coverage text which were highly negative, which is so strange. You have something here which shows you have a media which is in green, which is neutral, but you have a highly positive sentiment for this, whereas this one is extremely negative even for the abstract, but the media picture suggests that it's only neutral. So I said, well, this is somewhat informative, but it doesn't give me a complete clear picture. It allows me to say, hey, there was a lot of negative coverage in this short amount of time. Before that, it seemed like it was mostly neutral or moderately positive news. And there's a few things that I could take away from this when I looked at the actual numerical data. I found that the abstract and media side-by-side comparison, if the abstract is positive, then the title will be on the same track and vice versa for the negative. Whereas comparing the abstract to the title, on the other hand, are on the same page as above, but usually the media will have a more positive or negative value than the abstract on average. And then the media versus the title, it's the same. Now, there's two complete oddities or oddballs that I wanted to investigate. Two particular entries, all right? One of those happened on, it was like, I think it was around last month in August. One was September, one was August. This one in August was the actor who had cancer who died. And the most interesting thing is that the title for the article from New York Times, it was considered to be highly negative in suggestion because of probably these two words, I would suggest. But then it has a moderately positive media coverage text from this wording, and you would notice that it's highly changed because this is something that they want to promote in the media. For instance, like you see an abstract, wouldn't be exactly what they're going to show as a caption. It'd probably be this media thing. There's another thing with a good old fun Rumpelstiltskin, who has a positive, fairly positive title, but the media score is extremely negative. It's almost one of the lowest negatives you could get. When you start reading into this, I'm not going to read the words, but you could read into it and you could say, well, obviously somebody wanted to portray this as an extremely bad message if you look at the wording. The funny thing is when you look at the title, it doesn't suggest anything about that. Yeah, these are the same. Yeah, these are the same. So this is quite interesting because it looks like it's a totally different article. If you look at these two, they look totally different, which is so strange. So the moral of the story, there is some kind of connotation in the way that we use wordplay. That's obviously apparent. And it depends on the perspective and agenda of the person writing it. And this could highly affect things such as stock prices, people's perception of what's going on in society. And that's why text mining, natural language processing, and things like this are a valuable asset for people doing data analytics, machine learning, etc. So while I did not code today, I would like to say I hope that you could get a little bit of an idea of kind of some of the process of parsing out and dealing with these data. I highly suggest going on GitHub and taking my code and practicing for yourself and evaluating it and looking at the lines and see what it's doing. So please like, share, and subscribe. And if you subscribe, turn on that notification bell. I'll see you in the next video. Bye.